And as the world starts moving towards data-driven decision-making and basically with the emergence of big data, machine learning, and artificial intelligence, machine learning operations, or MLOps, as a discipline has been created to help make data insights become actionable. Data insights are essentially trained machine learning models. So why do they need to become actionable? They need to become actionable to create business value. So this means that you have teams of data engineers, data scientists, and machine learning engineers collaborating and using the tools and processes that they own and maintain to basically integrate these insights from machine learning within core business systems and operations to drive strategic business outcomes. So, for example, if you look at retailers, in order for them to drive more growth in sales, they would typically use historical consumer behavior insights to develop machine learning that is integrated in their e-commerce platform to help tailor shopping experiences to their target consumer segments. So this means that as a consumer who is interested in a particular product, or as a consumer who is price sensitive, I get an experience that is tailored to my shopping behavior. That's one of the applications of machine learning, and it definitely drives and optimizes for what we call conversion in the context of retail, where basically you convert that shopper from a lead into an actual consumer or a customer. Similarly, in manufacturing, for example, manufacturers are relying more and more on machine learning to optimize their plant operations. A common use case would be predictive maintenance, where machine learning is used to predict when a piece of equipment will need to be replaced or repaired. As a result, this guarantees little to no interruption in manufacturing activities. So in both examples that I provided, we're talking about value and a strategic outcome that an MLOps team would collaborate on to basically help deliver. So that's the general definition. That's what we mean here by operationalizing machine learning. Now, let's take a look at how MLOps is managed today as a discipline. Next slide, please. So in today's world, data scientists are tasked to develop and train models leveraging a variety of technologies and frameworks. And ML engineers, on the other hand, are tasked to make the models that data scientists create operational and actionable in the real world. So now, when I say this, there is some sort of assumption that there is a handoff that takes place between the data science and engineering teams when it comes to productionizing models, if that's even a word. However, while many data scientists may be happy to hand over their models over to the ML engineering teams for a production rollout, this process typically tends to be or tends to create technological and cultural silos that are hard to break down as teams and complexity grow. In addition to, which is one of the main concerns with this approach, that there's unclear ownership of the end product. So as a result, when you have these models that are now running in production, when they do start misbehaving, it can often lead to a significant effort to diagnose the issue. Basically, is it an error that in the production stack that caused the model's performance to drop, or is it something wrong with the model or the data itself, or is it something else? So this can typically lead to communication and coordination bottlenecks, as data scientists would not sometimes have access to the production environment to troubleshoot the models, or maybe the tools that are put at their disposal are not necessarily data scientist friendly. So it creates this sort of divide between the teams in charge of operationalizing the model, productionizing the model, and the teams that are that have developed the model. So it is really important, keeping that in mind, to go back to the real goal of MLOps and go beyond this mechanical definition of it, which is productionizing ML, and remind ourselves why we have invested in machine learning in the first place and the value we were looking to realize from it. By focusing on measuring the impact of machine learning would transition basically from a task-driven approach to a value-driven approach to MLOps. And that's what the last mile of ML is typically all about. So as we alluded to in the previous slide, the last mile of machine learning is focused on closing the gap between insight creation. So insight creation is what we would call in data science machine learning the trained model, and the value or ROI, return on investment, that it creates. In other words, the last mile of machine learning facilitates basically transitioning from experimental AI to industrialized AI. Today, when we look at the companies who are developing and operationalizing machine learning, with the exception of a few companies, most of the MLOps efforts are concentrated on the insight creation part, which explains, as we saw in the previous slide, the variety of solutions and technologies we find out there that help with data prep, model training, and model deployment to a certain extent. So when it comes to value realization from ML, which revolves around making AI-enabled decisions and being able to easily measure the impact of AI to take the necessary actions, there isn't as much concentration. This could be attributed to the fact that maybe there's an existing perception that practices currently applied today for software deployment or software development, or even DevOps, can be repurposed for machine learning. That could work on a smaller scale, but when you start looking at complex models, when you start looking at basically operationalizing large-scale machine learning, basically that perception comes with these challenges. So scale is definitely one of the main challenges, as in how do you start basically scaling the tools and infrastructure to deploy and serve thousands of complex models across different data modalities. So again, if you work across structured data, unstructured data, and you develop series of models on those data elements, when it comes to deploying them and serving them at scale, that could, some repurposing some of the existing, infrastructure that is not necessarily built for machine learning could be extremely challenging. And with that comes certainly operational efficiency. So as you start scaling your models and your data, does your MLOps team need to grow exponentially too? The obvious answer is no. So that's another variable that we would need to keep in mind as we look to industrialize machine learning. And then repeatability. So when you industrialize something, it has to be repeatable. How do you find consistent processes and methods that allow you to get value out of your machine learning at scale? That is a really important question to answer. And then, of course, if you have scale, operational efficiency, repeatability, what kind of actionability you have over the insights that you get from your machine learning now that it's deployed and industrialized. So there's no, as one of my previous product mentors used to say, if you cannot measure it, you did not ship it. So as you scale your machine learning operations, do you have the necessary visibility to be able to take corrective and preventative measures in a timely fashion? Those are really the questions that we need to answer when it comes to the last mile of ML to essentially achieve the value or transition MLOps from being task-driven to value-driven. Next slide, please. So how does Wallaroo think about the last mile of ML? So at Wallaroo, our mission is to help our customers realize the value of their investments in AI and machine learning, which is why we're constantly investing in building a technology that streamlines the last mile of the ML journey. Because we know what it takes to industrialize ML, we have come up with basically what we would call a purpose-built platform that allows MLOps teams to deploy, manage, observe, and optimize their ML models in production at scale in a repeatable manner with optimal efficiency. So with that in mind, we are not looking, as this diagram suggests, to essentially invent a new way or dictate a new way of doing machine learning end-to-end, but rather integrate seamlessly with the tools and ecosystems our customers are using to get their machine learning over to the finish line and be able to scale it efficiently and drive meaningful ROI for their business. So we talked about Wallaroo. What is it exactly as a platform? So Wallaroo as a platform is 3 integrated components. We'll talk about these components a little bit, but we have what we call a self-service toolkit. This is the component that enables data scientists to upload, deploy, and manage their ML models in the Wallaroo platform. This comes with depending on the tools that you prefer. It comes with as an SDK, as a UI, and as an API to allow a seamless transition from training to production. We'll be able to show that in the demo a little bit, but this is one of the core components that we lean on to basically streamline the product experience as you, for example, train your models in a given platform or framework to be able to deploy them seamlessly without running into any operational or technological bottlenecks. The second component is the computing engine. So when it comes to model deployment, a lot of what we see today is focused on model-serving frameworks. Model-serving frameworks are definitely necessary to be able to serve predictions in production. But another thing that would be important is really understanding at what cost and what performance you'd be able to do that. So one of the things that we invested in at Wallaroo is this Wallaroo inference engine, or a distributed computing engine. And basically, it's a purpose-built inference engine that supports distributed computing in a way that it can scale up to 100,000 events per second on a single server, knowing that the industry average for inferencing is typically 5,000 events per second. So this is essentially, given our background and our CEO's background in high frequency trading, we started with something that can actually be purpose built, that supports large scale inferencing, and we know it can be applied and repurposed in a lot of use cases. And we've seen incredible performance with this with our inference engine, where basically deployments and models run between 5 times and 12 times faster than our customers' previous deployments, and they typically tend to leverage up to 80% less infrastructure. So these are numbers that we don't take lightly, and we're really proud to share here. But this is something that basically we want to continue to maintain and improve as we help our customers scale their machine learning operations. And then last but not least, the third component when it comes to the Wallaroo platform is observability. So one of the key requirements to being successful in achieving the last mile of ML is the ability to measure the impact of your ML and be able to take the appropriate actions. So the advanced observability component of Wallaroo allows data scientists and ML engineers to get the necessary model monitoring and explainability insights to know exactly what's happening and be able to take the necessary actions and address it in a timely fashion. Next slide, please. So what does the last mile of ML look like in Wallaroo? So because we have envisioned a platform where data scientists and ML engineers collaborate effectively to launch their models faster in production, scale their deployments, and management observability of ML to deliver actionable AI, we have focused the product experience in Wallaroo on 4 key elements. So when you hear us talk about our product experience, you will always hear these 4 things: model deployment, model management, model observability, and model optimization. And we'll dive into each one of those in the next 4 slides. Next slide, please. So model deployment, to explain that basically in a concise way, it is centered around a few capabilities, basically 4 critical capabilities. The first one is model upload. So model upload means that you are using the Wallaroo self-service toolkit again, the SDK, the UI, or the API, to convert models from any framework into an open format that Wallaroo uses to run the models. So if you are developing anything in TensorFlow, PyTorch, Scikit, XGBoost, SparkML, that model upload procedure comes with this conversion process that allows your model to run inside Wallaroo. And once the model is uploaded, there's another core concept that basically we have built and developed in our platform to essentially allow for these models to run efficiently and be managed efficiently as well. So this concept is called a model deployment pipeline. This is, as I mentioned, the core concept for Wallaroo, where the models run to produce single or batch inferences. So for example, if you have chained models producing a single output, the Wallaroo pipeline simplified the deployment and integration of these models with the systems that will be consuming their outputs using a single cohesive interface and no overhead. And lastly, we have this, as these model pipelines run, we want to make sure that they run efficiently. So we have this concept of auto-scaling. So when you do deployments at scale, auto-scaling is super important in a way that each deployment pipeline can scale up or down its resources utilization to ensure optimal performance and usability downstream for both the data scientists and the systems consuming the model outputs. So in other words, you have data scientists being able to manage models and run batch or single inferences at scale and be able to get the insights they're looking for, and the systems that will be integrated with the models downstream will be able to get the responses they're looking for, always with optimal performance and with a latency that is acceptable and according to the objectives that have been set. Next slide, please. So we talked about model deployment. We'll talk about model management. That's the second component, or the second product experience. So as part of model management in Wallaroo, we have introduced the concept of workspaces to help data scientists and ML engineers collaborate effectively on deployments. It also helps MLOps teams as they scale their deployments by adding more context and security around their model rollouts. For example, this concept is used by some of our customers to organize their rollouts by market or region or location, or even by team, depending on the use case. As part of managing their models in production at scale, data scientists can actually try different rollout strategies such as A/B testing, canary deploys, shadow deploys, and even blue-green strategies to identify the best models to run in production. So these are important concepts to keep in mind when you start scaling. And once that happens, how do you know, basically, how do you know how to replace a model once you know that you found a model that is running better in terms of performance or accuracy? So in that case, we introduced this concept of hot model swapping that allows for models to be replaced inside a given pipeline without actually shutting down that pipeline or without any interruption at the end of the day. Next slide, please. Now let's talk about model observability. So when it comes to model observability in Wallaroo, it is important to make sure that deployment pipelines are healthy and performing as planned with the appropriate throughput and latency requirements that have been originally defined. So here we're talking about performance and health. Having access to these metrics provides insights into any potential model or infrastructure actions to take. At the same time, we have this proprietary concept called the Wallaroo assay to allow data scientists to basically configure a set of validation checks and alerts to be able to monitor models for drift, basically. So you can even monitor data drift off of the Wallaroo assays. And last but not least, we have data explainability reports, global and local, that are generated against the models that were deployed. And these help data scientists and business analysts as well get an understanding of the attributes that contribute to a certain prediction or set of predictions to be able to know if essentially there's some fine-tuning that is required with the model, or if we are seeing things that are not matching what we have expected to happen when the model was originally deployed. And the final concept we want to talk about today is model optimization. So as part of our model optimization experience, we are investing in delivering what we call actionable insights to data scientists to be able to reactively and proactively tune up a given model. Additionally, and this is an ongoing investment for us, we'll be investing in automating the retraining and redeployment of models, either partially or fully, depending on the use case. So partially means that it will be a certain attribute of the model that will be tuned up and redeployed, or fully means that the entire model will be retrained and redeployed. All right, so now on to the fun stuff. I'll do a very quick demo of the Wallaroo platform. So for this demo, what I'm gonna do, I'm gonna use the Wallaroo user interface to essentially spin up a few workspaces and show how I can deploy a credit card fraud prediction model. And once I have my model deployed, I will run a stream of inferences on it, and we can actually check out the metrics that come out of that model. So I'm going to go ahead and share my screen. I'll give it a few minutes or a few seconds, sorry. So now I'm in the Wallaroo user interface. Basically, what I'm about to do is can be done, as I mentioned, with the self-service toolkit, with the UI, the API, and the SDK. This is something that is very important to keep in mind because, as we mentioned, the Wallaroo platform integrates with the ecosystems that are available out there, and it's not something that has been built to basically reinvent machine learning or basically force a new end-to-end way of doing machine learning. So in this context, I have models that have already been trained. It's a credit card fraud prediction model. Now I'm looking to do a deployment. So my deployment will start by me defining a workspace. So by default, I have an existing workspace. I can go ahead and create additional workspaces. In this scenario, I'll just stay in my default workspace. And what I'm going to do, if I want to, I can actually have some collaborators that can help me with my model deployment. So my collaborators can be data scientists, machine learning engineers, because we'll be evaluating things around the model itself in terms of its quality, its accuracy, but also its overall performance. So it's good to have this notion of collaboration here. As I mentioned previously, workspaces are super important to help with deployments at scale. So if you're looking to have a rollout that basically spans multiple regions, multiple areas, or multiple markets, having this ability to organize these deployments by workspace can give more context to the deployment and management tasks that the MLOps team will be performing. So now that I have my collaborators set up, I can go actually and invite more. What I can do is essentially launch the Wallaroo SDK. So I'm going to launch a Jupyter notebook in my production cluster here to be able to essentially do a few things. Start a pipeline and do some early validations on the model before the model can actually be integrated with the downstream systems that we'll be using. So now I'm going to be showing a few things around the model artifacts, but also the model conversions and the model pipelines that are running inside Wallaroo. So I'll start with the model artifacts. Here I have this credit card fraud prediction model. It's an Onyx model. As I mentioned, we support any any model framework. So it could be a Keras, PyTorch, XGBoost, Scikit, SparkML, and what have you. And the idea is that we convert it to be able to run inside of Wallaroo, still in open format. The model can still be extracted out of Wallaroo if needed. But the idea here is that we are running it on our inference engine. So I'm going to quickly establish the connection here to make sure that I am connected as the person who connected to the SDK as the person who is actually logged into the UI. Now that my connection is confirmed, I'm just going to go ahead and list my workspaces to see what I have. And I'm going to actually connect into one of the workspaces just to make sure I'm in the right one. So I want to make sure I'm in my workspace. So from here, what's going to happen? I'm just going to actually initiate a deployment of a pipeline. So we mentioned previously or in the presentation that a model deployment pipeline is basically the vehicle that supports all the models that we're looking to put in production, and that's the interface between the models and the systems that will be consuming the outputs of those models. So in this one line of code here, I am performing two things. I'm performing the model upload. So my Onyx model is being uploaded to Wallaroo to become a Wallaroo object. Additionally, it's being deployed inside of a pipeline that I'll be creating. So my Wallaroo model is called CC Fraud Demo AI Camp, and my pipeline is called CC Fraud Pipeline Demo AI Camp. So what's going to happen here once I run this, which should take a few seconds, is that I am essentially spinning up a deployment that would normally, if you use containerization strategies or other deployment strategies, this is something that is time consuming and can have some overhead. This is one area where we invested heavily in streamlining deployment so that it takes only a few seconds and basically anybody can do it, including data scientists. So what do I have here? I have a pipeline that is active with a model that is running inside of it. Let's verify that. So again, self-service toolkit, I could verify it through the SDK, through the API, through the UI. Because we have the UI that is already, in front of us, I'm just going to go ahead and see what's happening there. So I have my pipeline that I just created. It is active, and it has my model running inside of it. This model here also can be represented in the UI. So we can see that I have this model that is running. It's running on this version. Model versioning and pipeline versioning are two important concepts here. So as we start basically replacing models or swapping things inside of a pipeline, we keep track of all of those activities so that as versions, so that we can always revert back if something doesn't work, or we can at least have full traceability and auditability of what happened. So this is my model, and this is the pipeline that the model is associated with. So I'm going to go back to this pipeline. Now, what I'm going to do, I'm going to stream a few credit card transactions on this pipeline. We can certainly do a test on one transaction, but I already have a stream of transactions that is ready to go. So I'm just going to go ahead and basically simulate it here in a way that my pipeline is going to start receiving some credit card transactions, and it's going to be predicting fraud at scale. So let's take a look at what that looks like. We're going to look at the metrics of that deployment. So now we're just waiting for the deployment to launch. Now that it's running, I can go back to the pipeline, and I should see a graph of my throughput and latency metrics showing up in a little bit. I can switch to the last 60 seconds if I want, the last 5 minutes, but that won't be necessary. We should start seeing the metrics coming up. So as the graphs build up, we can already see some of the throughput metrics here. We're seeing an average of basically 100 requests per second. That will continue to go up. In this demo, we would expect something around 150. And here's what we're seeing in terms of latency. So we're looking at an average latency of 100 nanoseconds. And in this case, I am running a cluster with 4 CPUs. So with that type of setup, we could basically see an average for basically an average of 4,000 requests per second. We see an average latency of 20 microseconds. So this is something that is running pretty fast. Again, it brings back the the background in high frequency trading, but a high speed or high performance compute engine is certainly something that all industries can benefit from. So as my metrics run, I can actually go and expand one of the graphs so we can see it build in real time. And we can also have real-time access to the logs, so we can see essentially what the model is returning. Here we have the output of the model, and here we have the input features of the model that we're receiving. So obviously these logs and metrics can be exported out to third-party tools for reporting, in addition to our native reporting that you see here with the logs and also with the UI. So that's about it for the demo. I wanted to make sure we have a little bit of time for a Q&A and see if there are any questions that we can answer here or any follow-ups that we can take.
Great, thanks. Thanks for the presentation and the demos. Yeah, just to remind everyone, if you have questions, you can post in the chat. I see we have questions coming over. And if you prefer to ask questions, feel free to raise your hand. I can unmute you you can speak to ask questions.
So, Younes, there are already some questions. The first one is, how is this different from Kubeflow and MLflow?
Very good question. So it's not supposed to be different. It's supposed to complement Kubeflow and MLflow. So I'll take the example of MLflow, for example, where you have your model registry. That's where essentially you can get to a point where your models are ready to deploy as I mentioned earlier, by integrating Wallaroo in your ecosystem. You can actually run your deployment and inferences on the Wallaroo compute engine in the context of a MLflow or Kubeflow integration, where basically Wallaroo is managing the inferencing and the serving of the models, in addition to obviously the observability that you get out of the models running inside of Wallaroo. And that observability can go back to the platform in which you're running MLflow. So if you're basically running inside Databricks, you can get those metrics back and run them inside Databricks. If you're reporting on those metrics outside of Databricks in a Tableau or Datadog, you can run them as well. So the idea is that it complements your MLflow deployment, and on top of it, you get to leverage the management and deployment capabilities of Wallaroo to be able to run your production workflows at scale.
Follow-up question for that one. Do we have any functionality for metadata management?
Yes. So the functionality for metadata management would mean that there are two types of metadata. In Wallaroo, you have the objects that are running inside of Wallaroo, being the models and the pipelines. So those are fully auditable, fully traceable, and fully manageable inside of Wallaroo. In addition to those, you have your model artifacts that you actually bring into Wallaroo. So you have two things. You can actually store them inside of Wallaroo and leverage the artifact management capabilities within Wallaroo to share those artifacts or keep track and have full traceability over those. And at the same time, you have a linkage between the resulting models and pipelines and the artifacts that you have transferred over to Wallaroo. So you have that full linkage, as I mentioned, and full management of your metadata inside of Wallaroo.
Cool. Okay. A few more questions coming in. One was around how does your solution interact with AWS and other clouds? You can see all the instructions to install on different cloud service providers on our documentation, which I just shared. This is an interesting one. Will things like Wallaroo reduce the need for ML professionals due to its automation? Will automation be making data professionals obsolete?
Not at all. Not at all. We're not actually making them obsolete with Wallaroo. We're making them efficient with Wallaroo. So there are things where, as I mentioned, Wallaroo installs and integrates in a given cloud, on-prem, or edge environment. So we definitely need the DevOps and MLOps teams there to help with these. But the idea is that when it comes to scaling the deployments, when we start talking about thousands of models running in production, the idea is that you want to make sure these teams have the observability to understand what's going on, be able to take the necessary actions, rather than actually being operationally burdened by either monitoring all the time or basically tweaking the infrastructure all the time because there isn't enough compute, or the pipelines are not running efficiently. That's really what we strive for. It's really driving operational efficiency, not just for the ML engineers and the MLOps engineers, but also for data scientists. That was a great question.
Yeah, that was a good one. Another question, there's two related. It's all around how much of a role does Wallaroo have to do in model training? So the first one was, can Wallaroo be used for training? Will it be able to use the Wallaroo observability if we're using AWS cloud? And then the second similar one was model deployment, model management, model observation, and model optimization. But what about model development? What is the proportional percentage for above each step across the entire pipeline? Yes. So how does it configure, like, in terms of model development, assuming, I guess, no model to begin with?
That's another great question. Our customers ask that question all the time. So the short answer is that we are not doing training or data wrangling inside of Wallaroo. We're focused really on the last mile. That being said, there are two things to keep in mind. We are here to integrate with the platforms that are basically specialized in training. If you remember, the early slides and the concentration of platforms that are out there for model training, I think there is enough that we don't need another one to go and solve model training. But in the context of the last mile, we are integrating, and we're looking to make that transition from training to the deployment or training to production pretty seamless. So there's no issue there. But we cannot discount the fact that when you have deployment, management, observability, and optimization in the context of production, there needs to be a link back to training. So we're not basically going to be doing retraining in Wallaroo, at least not in the near term, but we are investing in things that help re-trigger the training from Wallaroo based on, again, the insights that we're gathering. And the idea is to basically look to tighten the feedback loop between training and deployment by producing as many actionable insights in real time as possible to help basically streamline the trip back to training and come back into deployment. So that's one of the things that we mentioned about model optimization that we call retraining and redeployment, but with that in mind. So that's the what we mean here by Wallaroo doing training.
Another good question coming in. Can you elaborate on use cases currently using Wallaroo? And this is assuming you can share like the general use case with customers you already have.
Yes, we actually, the use cases are also on the Wallaroo website, so I can certainly take a follow-up and point you to the page where the use cases are. But I can share a couple of use cases. We have one in retail where basically Wallaroo is used for dynamic pricing, and dynamic pricing is essentially a very tough problem to solve because it factors in a lot of attributes around the consumers and their behavior. So when I started introducing MLOps today, I talked about the idea behind, deploying models to drive a certain value. Like in this case, the value is that we want to make sure that these customers convert, these leads, convert to customers by having the appropriate price shown to them at all stages of their shopping experience. And that price is shown dynamically based on who the customer is, some of the insights we have on them, like their shopping behavior. Are they price sensitive? Are they location sensitive? Are they quality sensitive? Those things are one of the things that we're working on with our customer. And the challenge there is really not the deployment of the first model. It's when you have basically this running in a lot of like thousands of retail locations across the US, for example. How do you know that you're always, developing and deploying the appropriate pricing model? And how do you gain visibility on those? How can you take action on these models when the pricing, starts to go haywire? And basically you're seeing a drop in conversion in a given market. So organizing these models by market or by retail location and understanding and getting the insights in real time to be able to take the appropriate action, not to mention the ability to try multiple deployment strategies to know which pricing model works. It's really just, it's really like taking what happens in the e-commerce experience itself and doing it in the context of the models that are powering that e-commerce experience. So that's when we start talking about scale, that's really where we start seeing some challenges and things that we need to get ahead of. Not to mention that, most of the customers we have do not have, or, basically the idea is not to have thousands of data scientists on staff doing this. The idea is that you want to have a small enough team of data scientists that you can scale to, up to thousands of models without burdening down with what happens in terms of observing the performance of the models, or basically being able to understand how to take the necessary actions. I hope that answered your question.
Yeah, I think so. There's one more question. We'll keep going for now. So keep the questions coming in. There is one more question around model pipeline interpretability. What info does Wallaroo provide when things go wrong in deployment? So what are some of those metrics that you're looking at in terms of model observability?
So in terms of metrics that we're looking at health metrics. You have the latency and throughput. So latency and throughput are important in the context of what are they driving downstream. So for example, if you have pricing and you have basically a model that is expected to return a price in, say, less than a second, or less than 50 microseconds. Now we're starting to see that the average response time is 100 microseconds. So that's one of the metrics that you can get in observability in terms of the performance of the model, because that slowdown in performance has basically a ripple effect on the end user experience within the product or the system that is consuming the model downstream. So that's one layer of observability in terms of the health of your deployment pipeline. The other layer of observability is basically what we call model drift or data drift. So model drift, the way it's set up today in Wallaroo is actually, we have this concept called a Wallaroo assay. Assay is a very scientific term. In English, it really means a set of configurable validation checks that someone being a data scientist can actually set up based on their understanding of the model. Nobody knows their models better than the data scientists who develop them or who are close to them. So these validation checks can be configured on these models so that they produce the necessary alerts to data scientists on potential model drift or potential data drift. So a model drift means that now you're basically you're expecting predictions within a certain range, and your predictions now are outside of that range. So the model is completely drifting here. Or data drift means that some of the attributes of the model are starting to be outside of the range that you have defined. So that's those two layers of monitoring are available in Wallaroo, with the idea that you can sometimes still see an acceptable prediction, but the input or data leading up to that prediction is no longer within range. So an example would be, for example, staying on the pricing use case. You are expecting, let's say, your persona to be consumers between 18 and 24 years old, to be able to get the predictions. You're still getting the predictions and the prices that you're looking for. You're still maybe seeing acceptable conversion in the in the e-commerce funnel. But when you look at the data that you're getting, you're seeing now that basically your customers are between like 36 and 50. So this is very insightful in terms of what happens upstream. Now, I am pricing in a way that is attractive to a different consumer segment, which means that from a business perspective, my marketing strategy needs to maybe start to account for customers between 36 and 50. And whether it has to be the same marketing strategy as what I use for the consumers between 18 and 24, or it's a different marketing strategy that's up to the business and to the basically the metrics that we gather. But that's really the benefit of having model drift as well as data drift, because data drift helps you understand the new trends and what you're basically the type of business that you're attracting, for the lack of a better word.
There's a few more questions. If anybody has any other questions, please ask them now. We'll probably be wrapping up soon. I want to make sure we get everybody we can. One question in terms of how does it integrate with Spark Streaming or Flink? How do I call a deployed model in your pipeline?
So in terms of the integration with Spark, that's something that we'll have to understand based on the use case. Obviously, we have our own MLOps APIs that allow you to integrate your basically the environment in which you train the models with if it's Spark ML, for example, with our own model registry. So it will obviously depend on the use case, but as part of that integration, we do support a conversion from your Spark ML model into Wallaroo so that it runs on our engine. And I forgot the other question, Carl. Can you repeat that?
It was mostly around Spark. Let's see, let me find it again. How do I call a deployed model in my pipeline?
Oh, and then getting a deployed model in your pipeline basically can be done as we showed via the SDK, the UI, or even the API. As you list the pipelines that have been deployed, you can actually you can see the models that are deployed inside of the pipelines and understand basically what models are actively producing the inferences. Something we didn't show today in the demo, but we have in our documentation, in our tutorials, is this notion of basically rollout strategies where you have inside of a pipeline, you can have the primary model, which is the one that produces the inference, and the challenger model, which will be running in the context of a canary deploy, for example, where it's running in the background and it's receiving the same data and producing its own outputs that you can compare with the primary model. Same thing with A/B testing and other, rollout strategies that you can adopt there. But it's all available in the again, in the self-service toolkit, being the UI, the SDK, and the API, to get that information based on, a model that you're looking for in particular, or a pipeline, or a model inside of a pipeline.
Great. Let's do one more question that I missed earlier, since we're talking about tooling. This is from Chow. Question is, this looks great. I'm just wondering, with that convenience to deploy directly to prod, does that raise some security concerns, as I'm not sure there is some kind of gatekeeper code review process in this tool?
Yes, so that question comes up a lot. So the gatekeeper code review process is something that can essentially happen inside of Wallaroo. That's why we invested heavily in the workspaces and collaboration, where you can actually have these reviews and collaborations on an ongoing basis between data scientists and machine learning engineers. That's actually one way of doing it inside of Wallaroo, using our own artifact sharing and collaboration experience. You can also leverage the APIs if you have a code review process that is upstream of Wallaroo, where you just basically want to do deployments, live deployments inside of Wallaroo. That's also acceptable, where you can actually have, for example, if you use a CI/CD mechanism to do code reviews, that's perfectly fine. And basically you can trigger the deployments of what has been reviewed and approved from your CI/CD directly into Wallaroo. So, the model, as soon as it lands there, it can be quickly validated and it can be quickly served in production. So those are, two deployment strategies that are perfectly acceptable. When it comes to security, again, we run inside your own ecosystem. So we're not a SaaS offering. So this means that whatever security protocols exist within your own cloud, within your own enterprise, within your own set of systems, that can all be applied inside of Wallaroo. We're not coming up with any with our own security protocols. We're integrating with the security protocols that our enterprise customers and our customers are adopting.
Awesome. Cool. I think that's all the questions we have.
So I think to close this, one thing is, I don't know if you've seen any of our blogs, but we've recently announced a free version of our product. It's called Wallaroo Community Edition, or Wallaroo CE. You can sign up for free. You can see the link here on this slide, and obviously you have access to a few tutorials and documentation to be able to install it and run it in the cloud environment of your choice. So yeah, we'll be more than happy to help you get set up. If you have a use case that you want to work with us on, you can reach us at community@wallaroo.ai, and we'll be more than happy to sit down with you, work on a real use case, get your feedback. Obviously, we're still working on improving the product. We're not looking to throw technology at the wall, and it's a collaborative space. So we want to build a community. We want to be part of the community. So any insights that you might have that can help us improve the product to help you at the end of the day do your job faster and more efficiently, we're here for you.